So far today, we've gotten through these notes here pretty quickly with most or the other two classes. Probably the same deal with you guys. We probably went for a good 15 minutes to start up on the problems without any hassle, and people have been knocking it out. So let's go through and talk about what's called a mid-segment. I apologize for spelling mid-segment incorrectly. I didn't even notice it. So, if we look at what's called a mid-segment, what do you think the word mid-segment stands for?
Middle segment.
The middle segment, okay? Now, if you have a triangle, where do you think the mid-segment might occur? If they're connecting the angles, wouldn't that be the size of the triangle? Where do you think the mid-segments might run into? Mid-point. Great idea. Mid-segments. This is really straightforward, guys. A mid-segment is a segment in a triangle that connects midpoints. So if you have midpoints, in a triangle you obviously have three sides. We agree on that? Which means we're going to have three midpoints. Thank you. So if we have three sides, three midpoints, how many mid-segments do you think we can create? Three. I know, that was tough. Good job. Okay. So mid-segments, they connect midpoints. There's three parts to them. They connect midpoints. They are parallel to the side they don't touch. So this one here will be parallel to the one on the bottom. This one here is parallel to the one on the right. This one here is parallel to the one on the left, and so on. Okay. So they're always parallel to the side they don't touch. And their length is equal to, why, hello? Buongiorno. And they're equal to half the mid-segment equals half the length of the side it does not touch. Okay? So this is really scary. I'm sure you'll be all right. Not having. He takes everything.
No,
Take it again.
I didn't.
There are no markers.
Yeah, I just came up with the idea. She did.
Oh, there's one on the floor.
Yeah, you put it back. I know. I don't put it back.
I'm telling you, that Loft House kid,
Troublemaker?
he's something. So, what's that?
A square.
It's a triangle.
Who really knows?
What is this? A mid-segment, because it connects the midpoints. Now, if the side it doesn't touch is 14, how much is the mid-segment? It's 7. Okay, good work. Let's try this again. What is that segment? It's a mid-segment. Let's say this mid-segment is 13. How much is that side? Okay. Now what I'm showing you here is that you can do this one of two different ways. We wrote it out, the most generic way that they write it is that the midsegment's always equal to half the side it doesn't touch. Well, if that's equal to half the side it doesn't touch, wouldn't I, another way to say that is, if I double the midsegment, it equals the side it doesn't touch. It's just another way to write it. So these are the three main parts of this. It connects the midpoints, it's parallel to the side it doesn't touch, and it's equal to half the side it doesn't touch. Some people though, and me in particular, I also write it out like this. Can I slide this all the way up so you guys can see it better? If I double my midsegment, it equals the side it doesn't touch. The reason why I write it out that way sometimes, because it gets rid of the fraction. It gets rid of the fraction. Okay? It's just an easier way to do it. Your book will write it as halves. Most textbooks and things do. But it's easier sometimes to say, well, if I double it, it equals the other side. There's less possibilities for us to screw up, let's just say that. Is that fair? So if I gave you the midsegment was 13, to figure out the other side, you multiplied it by 2. We had the other side to get to the midsegment, we cut it in. Okay, we cut it into 2s. Okay, I'll give you that. You cut it in half to figure out the value, so or you cut it into 2 equal parts. I liked your corresponding tacos thing. That was funny. It's like 7 o'clock in the morning from grading those things, and I was going to read the corresponding tacos and think, so, well, what a fajita. That was funny. Thank you. I know, she said she was going to do it. It was great. So, okay, are we scared yet for what could go wrong here? Because usually, no, I didn't scare her, but she bugs her around. But usually, you guys are waiting for the other shoe to drop, and you guys get all freaked out here. So let's just jump right to the spot where you guys are just going to go, oh no, I don't know what to do.
I don't know what to do.
So let's draw this diagram and work it out. Here's what we do. In this diagram, try to make this a little bigger so you guys can see it. In this diagram, you are given some information. We are told that in the triangle XYZ, that you have midpoints U, V, and W. It then gives us some values. So when you're given information like this, your best bet is to always mark up your diagram. Okay? And I'm going to show you a really cool thing that happens here. Well, whatever, maybe not cool, but it's easy to see. If U is the midpoint on this side, that means we have these two segments that are congruent. We're okay with that, right? It's kind of off our progression. It just goes right down the line. Nothing crazy. I do the same thing here. W is the midpoint. These two are the same. Be okay with that? Then I do the same thing on the other side. I have another midpoint at V. So these are the same. Now, before I get into using all this algebra here, or let's just write it out first. We'll come back to that. We know that the segment here, UW, is 4x minus 1. Now that one is the mid-segment. It's parallel to YZ, and it's equal to half of whatever YZ is. We okay with that? Because it doesn't touch YZ. This whole thing is 5x plus 4. You double the mid-segment equals So if I double that mid-segment, it equals the other side. So you just write it out. 2 times the quantity is 5x plus 4. Where are you going to screw up? What's that? No, go ahead. I didn't hear all of it. Yeah, usually what happens is you guys will distribute to the 4, but you'll forget to distribute to the 1. Okay? So do me a favor. Whenever you're doing distributive property, to make sure that you don't screw up, draw your arrows. Draw your arrows to show that you're distributing out. Okay? It's just a little safety thing. That way you don't forget to send it to both parts. And then you just write it out. 8x minus 2 is 5x plus 4. And now you're at a point where you've got a very straightforward equation with variables on both sides. So when you have variables on both sides of an equation, who are you going to pick on? Pick on the little guy. Okay? So what are you going to move, an 8x or a 5x? Good. How do you move it? Good. So if I subtract the 5x to both sides, what do I do with the negative 2? Add it to the other side. Very good. 8 minus 5. 4 plus 2, and x is 2. Okay, you get x is 2. Which means we need to figure out what yb is. So let's check it first to see if it actually worked. What's 4 times 2?
8.
Subtract 1. You get 7. All right, that wasn't too tough, was it? Okay. What's 5 times 2? What's 10 plus 4? 14. What's half of 14?
7.
So now, what I want you to see here, I know it's crazy, right? Does 7 equal 7? And does 7 equal 7? How many tick marks do both of these guys have? They both have 3 tick marks, which means this segment also should have how many? 3.
Oh, so we have to mark that?
No, what I'm just showing you is that this is what happens. What happens here is that when you start to look at, can you guys see the whiteboard okay?
Yeah.
What happens when you have mid-segments? When you have these mid-segments and you know that, if I just say that those two are the same, if I say this is x and this is x, how much is that whole side?
2x.
2x. So the whole side would be 2x. So if the whole side is 2x, this is the mid-segment, which means it's half of 2x. What's half of 2x? X. Which means it has 1 tick, because it's the same value.
No, I was just asking, like, if you get that problem, you have to say that that is congruent.
Oh, no, you don't have to do that, but I'm just showing you it's a little bit of a shortcut sometimes, depending upon what you're trying to find. Okay. Same deal here. If the whole thing is 2y, how much is this? So that means these two guys are the same, as well as this one. G, what do you think is going to happen here? And you wind up with 4 congruent triangles on the interior then when you draw that out. It's really, really not that difficult today, guys. You should be very pleasantly happy. Yes, ma'am?
Is there always going to be 4 interior triangles?
Yeah,
Or
well, unless it's not drawn fully. You remember all that first 2 examples I showed? They just did one part of it. Sometimes they do one part, sometimes they do 2 mid-segments, sometimes they'll show all 3. It just depends on the problem.
Okay.
You can have anywhere between 1 and 3 parts to this. Okay. This example here, even though they drew in the other 2 mid-segments, you're really only looking at one of them. You know, in this case. Whereas if I go back, here they were using 1.
Oh.
Here they're using 2 of them. You got the whole thing, you got the small part, find the other things. Find this one, 14. Double that and you get 53. That's all it is. It just depends on what diagram you're looking at.
Okay.
Okay. And it's gonna be really, really obvious.
Okay.
Okay.
Still sketchy.
Let's try this. Same idea here. Same basic idea, guys. Also, some of these problems, what they might do is write out 3 problems that go with one diagram. So you wind up reusing diagrams a couple times. I mean, it's not very difficult to figure out what they're doing here. You're just reusing parts. Or reusing pictures, excuse me. So in this one here, you've got D, E, and F are midpoints, which means that you've got these different mid segments, D, E, E, F, and D, F. All 3 of those guys are mid segments. Bless you. So when you have a mid segment, you're equal to half the side you don't touch, and you're parallel to that side. Or if you say that you double the mid segment, you equal that other side. It works the same way. So if you start filling in the blanks of what you know, if I know that DE is 4x plus 5, and this whole thing is 3x plus 25, what do I do algebraically to write it out to figure out what x is?
2 parentheses 4x plus 5
Perfect. Very good. We double DE, and it equals GJ. Double the mid-segment, it equals the other side. Poke your eyes out more than anything. More so than normal. Figure out the pattern of the blinking. Is he blinking more so actually trying to help you? Trying to help it?
Oh, I know where
Double 4x plus 5, you get 8x plus 10. It equals 3x plus 25. Pick on the little guy again. This is the only time that I will condone bullying, unless you're picking on Miss Toad, but that's okay. Nothing, I didn't say anything. What? Subtract 3x from both sides, subtract 10 from both sides. Are we okay with that? Move the 3x, move the 10. And what's x? 3. So now you go back to the idea of filling in the blanks to figure out what you're trying to solve for. I think it was asking to figure out what DE was. Well, what's 3 times 4? Plus 5? 17. Now, if we did this correctly, if this is 17, this should then equal 34. Do you guys agree? Well, what's 3 times 3?
9.
What's 9 and 25? We math. Okay, so we're good there. Okay. Are you still worried?
No.
kind of,
Shouldn't be.
it's sketchy.
It's sketchy. Right. Here, let's do the same thing. You reuse that diagram with these two. You've got 2 problems here. Reuse that diagram. Well, actually, just bring the diagram over. Take a couple minutes, reuse that diagram, and solve for x and both, or solve for whatever they're asking to you for both these parts. Remember, they're independent problems. Okay, they're independent problems. They should have used different variables, but whatever. So, I'm guessing, for the level of craziness that's going on around here, that this stuff is pretty silly easy, right?
Yeah.
You okay? You mad at me already?
No. What did you say though?
He said he doesn't condone bullying unless it's for bullying.
But I would never condone that. Unless she will. That's okay. So EF is your 2x plus 7. GH is the 5x minus 1. Algebraically, what do?
it's equal each other.
Not quite. What do you have to do to one side, though?
Oh, multiply by 2.
Which one? The 5x or the 2x one?
The 2x.
Good. So we double the 2x plus 7.
Wait, so it's always the midpoint one that you times by 2?
Yep, that's the whole idea. You double the small one, it equals the whole. Don't forget to distribute to both parts. Pick on the little guy.
Minus 4x.
Subtract 4x, same time, can I add 1?
Yeah.
Whew, that was tough. So double 15, what do you get? 30 plus 7 is? 37. Double check the other side. 5 times 15 is how much? It's 75. Subtract 1 and you're left with? Hey, is 74 or doubled 37? Yay. And you do it one more time. Let's see, we change this up. We have the whole thing, oops. The whole thing is 8x minus 2. And the interior part is 2x plus 11. Which means I double the 2x plus 11, and it equals 8x minus 2. Distribute out, 4x and a 22. Subtract 4x, add 2. Six times 4 is how much? I'm sorry, 6 times 2, excuse me.
12.
12, add 11, you get 23. 8 times 6 is,
48.
subtract 2 and you get,
46.
did that work out?
Yep.
Could we make this more difficult?
No.
Oh, well.
Yeah.
Whoa, 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 what?
There's some, I got x equals 2.
How'd you get x equals 2?
I don't know.
Did you write something down incorrectly?
My nose is
Nothing. Subtract. We wrote it here. So make sure we write it.
Don't just don't.
All right. Hey, you know what? That's actually kind of a good thing. I'm glad you kind of screwed up there. This actually happened. I think this actually happened a couple of times on the test. There were a couple of parts where you guys wrote down from what was given in the problem, but you accidentally wrote it wrong in where you did your math. But let's say you did all your math right with the wrong value. Did I mark you wrong?
no.
No. No, and that's the whole idea of showing your work, be able to figure out where you done goofed. Now, in your case, you had it all set up that it was double, write it over. You set up your stuff. If you had continued with that, you probably would have figured out right away that when you substituted in 2, you got 15 and something else. You would have said, "Oh, what did I screw up?" And you probably would have gone back and said, "Oh, I'm a knucklehead."
That's what literally happened in that whole test, but I didn't have time to fix it, so.
Gotta work quicker. Okay? You gotta work quicker. We weren't supposed to be that long on that one. Really. That thing mirrored that review stuff big time. Okay? I only have a few problems for you guys to work through tonight, but I do want to show you where to find them again, in case you forgot. When we are going for the book.
So the website's back up?
Yeah, the website's back up and running.
Have you found that this like
No,
papers haven't passed mine still is missing.
I don't even know. So real quick, shh, guys, come on. Gee, what chapter are we in now?
5.
We're in chapter 5. So if I click on chapter 5, where do you think I might be able to find where the textbook is located? Oh, wow, look how obvious that is. So if I open that, gee, where do you think it's going to open me to? Chapter 5. So remember how this worked last time? The PDF files are so big that they're done by 2 chapters at a time. This will be chapters 5 and 6 are in this PDF file, so I'll just redo it when we get to chapter 6 as well. I have you guys working on page, it's 298, I believe. Yeah, it's on page 298. numbers 3 through 11, I believe, and then it's 24 through 26. Yep.
All of them.
Yep.
Oh, that's 2 problems, 3 problems. I'm stupid. 3 through 11 is.
I want you guys to work on those. Pull open the book, it's there. Otherwise, give me a second. Once you guys write this stuff down, I will put that up on the smartboard as well, so you at least get the first few problems in. Through 26. Yeah, there's 3 of them. It's just like those last algebra problems we did a second ago. They look the same way.
Page 298.
So here's your first 9 of them. With any luck, you'll probably be able to knock this out of here before you even get out of here. All right?